Hey everyone, and welcome to this ultimate guide to Pandas tutorial. Today I'm going to be going over Pandas and kind of what Pandas is and what it can do, showing a couple of different things with the data that we'll be working with. Pandas actually is probably the most used package in Python, I would say, if you're doing data analytics. It allows you to work with data such as relational data in tabular format, as well as you can use data such as time series data. So Pandas is actually a great package and library to have. So the easiest way to get started with Pandas is just to start working with data and using some data. Today we're going to be using data that I downloaded from Kaggle. It's all the Netflix movies and TV shows. It's just a CSV. So you can come to this website and I will link this in the description. You can download it and you can work with the same data if you want to follow along. And we'll just kind of go over some of the core functionalities of Pandas and some different things you can do with Pandas to manipulate the data, read in the data, and everything else that you can do with it. So let's jump into it. So Pandas, like I mentioned, allows us to work with data and kind of manipulate data, especially if that data is in a tabular format or time series format. So how we get started with Pandas is we just need to import our Pandas package. So we'll just say import Pandas as PD. So this is common in data analytics, data science, to import Pandas as PD and just use PD as the abbreviation for Pandas, the package. If you don't have Pandas installed, then you actually need to make sure that you are installing it using pip install or conda install, however you need to install it, so that you can have it ready to use. We're just using it in Jupyter notebooks, but you need to make sure that you have previously installed it, and as well make sure that you're upgrading it or using the version that you need. So we'll just run that and we will import Pandas. So the first thing we're going to look at is something called a data frame. So a data frame is just kind of like a spreadsheet. It has rows and columns, which we call columns and indexes. So what we're going to do is we're just going to create a data frame first from scratch. So what we can do is just say df, and once again df is a common acronym for data frame, just kind of a short way to type it so we're not having to type data frame every single time. We're going to say df equals pd.dataframe, and dataframe has a capital D and a capital F, and then in parentheses, and we can do that. So right now our data frame is actually just going to be empty. It's not going to have any data. So if we just type in df, we can see it's empty. So how we add rows and columns is by using a dictionary, is what it's called. So we're going to create a dictionary like this. And first we're going to put in our columns and then the row data that we want. So we want to call our column A. So we'll say A and then a colon. And then in a list, we just need to pass in all of our data. So we'll just say 1, 2, 3, 4. Or 5 or 4. There we go. And then comma, and then we'll do the same thing for B. And we'll just say 5, 6, 7, 8, or 4, 6, 7, 8, I don't care. And then C, we'll do the same thing and we'll just go 9, 10, 11, 12. So now that we have this, we actually have our data frame created, and we can type df again, and as you can see, our column names are A, B, C, and then our indexes, our row numbers are 0, 1, 2, 3. And here's the data that we're filling our columns with. So a lot of times actually we aren't going to just create a data frame from scratch like this unless we're kind of doing an example. Most of the time we're going to be getting data from somewhere, and we are going to be doing that with CSVs or reading it in from lists. So what we're going to do here is we're going to upload the data that we download, the Netflix data. And this is another cool thing about Pandas is it allows you to read in data super easily in a super clean format. So we're just going to say df again equals pd.read_CSV. And there's a lot of different things. It doesn't have to be a CSV. It can be a JSON. It can be a Parquet. It can be a lot of different things, but read underscore and then the file name is usually what it is. And then you pass in the path in parentheses. So the path, these are both in the same folder. So it's just called Netflix_titles.csv. We can run that. And now if we can see that this ran correctly because we didn't get any errors. So now what we're going to do is we're just going to kind of see a couple of ways that we can explore this data. So if we wanted to see the first 5 rows, we could do something called head. So we just type in df.head with 2 parentheses. And this shows us the first 5 rows of the data frame. And we can do the same thing for the bottom if we do df.tail. So we'll say df.tail. We run this, and now we can see the bottom 5 rows. So as you can tell, this is row 0, 1, 2, 3, 4, and then it goes all the way up to 7,786. So that's a lot of rows. We can also see the shape of the data frame and see how many rows and columns it has if we just type in df.shape. We run that and we get 7,787 rows, 12 columns, as we can see. So that's a good way to kind of get a couple of summary statistics. If we wanted to get a list of all the column names, we could type in df.columns. We do that. So this gives us just a list basically of all of our column names. That's what it returns. If we wanted to see the data types of every column, we could say df.dtypes. And this is how it shows us the actual data type of every column. Another cool thing that might come in handy sometimes is something called transposing, where you flip the rows and the columns, and you do this just by saying df.T. So now we can see the columns are now our row names, and now we have all of our rows up here. But since I didn't say df equals dft like that, it's not saving, it's just showing what it would look like if we were to do that. For now. Something else that you might want to use for when you are just kind of looking at the data frame and kind of exploring the data frame a little bit is you might want to sort by values. So say you want to sort by the title. You can say df.sort_values, and then in here you say by equals, and then just the column name. So our column name is title. We run that, and now you can see it is sorted by title, where hashtag is technically number 1, and I believe those are, I might be wrong, but it looks like it's Japanese characters, Japanese and South Korean. Japanese and Korean, I don't know what these ones are. This looks Korean, this looks Japanese. I'm not sure though. I don't speak the language. Another thing that you might end up doing with Pandas is creating a copy of the data frame. This makes it so that we're actually just creating an exact copy of our data frame, so they're not the same thing. So something you might do is df2 equals df.copy, and it's literally the exact same thing. So that is how we do that there. Another thing you might want to do is if you just want to see a single column, you can do df and then in brackets you can type type. So if you do this, it returns you the actual column for type, which is it's either a TV show or a movie. Another thing you can do is you can just type in df.type and it returns the exact same thing. So you can do dot type or you can do df these brackets with the quotation. Some prefer it some way. Sometimes with different situations you have to use it this way. Other times you have to use it this way. So it's just a little bit of kind of trying to figure it out. And then another thing you can do is if we want to see, for example, how many TV shows there are in this column and how many movies are in this column, we can just type in df.type.value_counts. And we run that, and we can see we have 5,377 movies, 2,410 TV shows. So that is kind of how you can do some brief overview of your data frame, kind of get a little bit more insight into what your data is actually all about. And these things are actually really important because you want to understand what your data is and how you're going to need to work with that data to be able to provide a correct analysis, or any sort of machine learning project. If you're working on that, is going to require, you're going to need to know more about your data so that you're not feeding it bad data into your analysis or your algorithms or whatever you're using the data for. One other thing we can do is, since we see here we have NaN, this stands for missing values. So sometimes depending on what you're doing, you can't have NaNs in your data. So what we do for missing data is we can say df equals df.drop NA like this. And this will drop every row that has NaN in it. So for example, it could have NaN here, it could have NaN here, it could have NaN in this column over here. Essentially, if there's an NaN, it's going to drop the row. So you can do drop NA, or you can do something called fill NA. So if we wanted to fill the NA, we could say df equals fill df.fill NA. And then we just say value equals, and say we wanted to fill it with zeros, just whatever. Usually you're only going to do this if you're wanting to fill, like if you're going to have a column that has a lot of NAs but nothing else does. Most of the time, it's just easier to drop NA than try and fill it. So that's what we're going to do. We're just going to drop NA. Now, if we wanted to, we can see exactly how that affected us. We can say df.shape just to see how many rows it got rid of. And as you can see, we are now down to 4,808 rows. So that is something that usually happens when we're working with data, especially in Pandas. We might end up dropping rows because it allows us to get the clean data instead of having a bunch of messy data. So another thing we can do to kind of edit the data and edit the data frame is we can do something called changing the type of the data frame. So if we recall, we ran the data types back up here and we saw that all these were object and release year is an int64. So object essentially just means string usually, and then int64 is a whole number of 64 bytes. So what we're going to do is I'm going to show you how you can change that from being an int64 to a string as well. So what we do is we just say, we're going to call the column name like we did before. We'll say df, and then we will say release year, and then we set that equal to df release year, and then dot as type, and then we put in quotations str, and that will put it into a string. So this is something that a lot of people actually end up doing, and we can confirm this as well if we just say df.dtypes, types. So now all of these are of an object, so release here. If we wanted to switch it back, we can just do this same thing. We'll copy it again, and instead of it being a string, we can just say int. And then we can run this dtypes again, and as we can see, it is now back to an int. So sometimes you might have numbers, for example, that you want to be strings, such as like a zip code or anything else that doesn't really need to have any sort of mathematical operations performed on it, but sometimes you might have it as a string and you need it as an int. So this shows you how you can go back and forth. You can do it with different ones. It doesn't need to be an int. They can be float as well. So you could do a float, which is just a decimal number. We are going to keep it as an int for this purpose. Another cool thing that Pandas allows us to do is it allows us to get quick statistical facts and kind of details on all numerical columns. So since release year is the only one that is it's the only one that is a number, what we're gonna do is it's just gonna show us that data. So what we'll do now is we will just do a quick couple of statistical summary stats for release year. So the first one is just called described, and this is going to give us some brief and quick statistical stats. So we'll just say statistical stats. It's going to give us some brief and quick stats on all of our numerical columns. So we'll say df.describe, and then we can do this. And now we can see that our count, we have 4,800. The mean release year was 2012. The standard deviation is 9.5. The min is 1942. Our max is 2021. And then these show like the different quartiles and everything. So that's kind of how we can do that. As well as we can get all of these values just by doing them themselves. We can say df.mean. df.releaseYear.mean. So it gives us that same number. And as well, we can do things like median. So I'll just copy these real quick and just kind of show you everything we can do. So we'll say dot median. So we can do that, 2016. As well, if we wanted to get the max, we could do the same thing, but switch this to be max. So 2021, df.releaseYear. And then we could do the same thing if we wanted to get the min. So a reason we do this is because say we wanted to actually create a variable such as, let's say we wanted mean df equal to df mean. So this actually turns that number into this variable. So if we call mean df anywhere, it's that variable, or it's that number. So that's kind of a couple of quick, easy things that we can do right there to get quick statistics and quick numbers that kind of help us understand the data even more. Another thing that you might want to be doing with your data frame is adding and dropping columns. Say that you have a column that you need. So if you need to create some sort of number, or you need to create a calculation from a column, you can do that. Or as well, if you need to get rid of columns, you can do that. First, I'll show you how you can add a column, and it's super simple. All you do is type in df bracket, and you just type the name of the column. So let's say we want new underscore column. And we will set this equal to 5, which means that every row is going to be 5. So now we can look at our data frame again. So we'll just do df.head. And as you can see, our new column for every row, we just have 5, 5, 5, 5. So it's pretty simple there. Another thing we can do is we can actually drop that column now if we want to. So we'll say df equals df.drop. And then in quotations, we'll say new underscore column. And after that, we have to put axis equals 1. Because when we're doing this, if we don't put axis equals 1, it's going to look in the row numbers for a new column. But essentially, that's not going to exist. So we need to make sure that it's looking at axis 1. Axis 0 is rows. Axis 1 is going to be our columns. So we can do that, and then we can look at it again. We'll say df.head, and it no longer exists. What I'm going to do, though, is I'm going to add it so that we can do a couple of other things with it. So now what we can do is we can actually perform math on these different columns. So say we'll look at df.head again. And right here, we have our release year is 2016. This is an int, and our new column as well is an int. So what we can do is we can actually add numbers between columns. So let's say we wanted to add, for every release year row, we wanted to add the new column row. So we could do that just by saying df.releaseYear equals df.new underscore column, we want to do plus, and then it's going to give us this right here. As well, we could just use numbers. We don't have to use columns. So say we want to do df.releaseYear equals, or we'll just say minus 100. So now this is if every release year was minus by 100. So obviously release year minus it by 100 probably doesn't do us very much. But say you had different numbers, or you were trying to do something different, it would be pretty simple just to create a new column. So we could create a new column if we want to, just by saying df minus 100 equals, and this will create this new column and set it equal to all of our release years minus 100. So we can do that, and I can kind of show you what it looks like. So now minus 100 is 1916, 1911. So we now have that column available if we want to use it. We can also do multiplication and division. So we'll just do kind of the same thing up here. So if we do df release year, and we can multiply it by our new column. So that's what it looks like when it's multiplied. And if we want to divide, we use the regular divide sign, and that gives us our division. As well, we don't need to use new column. We could be doing it by 1.5 or something. It would be giving us those numbers. So there's a lot of cool things that you can do with data frames and kind of with the math between different columns and different data frames as well. The next part that we'll look at is if we want to start filtering the data and only looking for certain values and certain parameters in the data frame. And we do this by using two things. The first one is called .loc, which we type by doing it this way, and then the other one is called .iloc. So loc allows us to enter in rows and columns and use that to filter the data frame, and iloc is more groups by integer position. So I'll go over some examples and kind of show how this can be done. So say we did df.loc and we only wanted rows 1 through 5. We could put brackets and do 1:5. And this now gives us rows 1 through 5. So this is the same thing that df head is giving us, but now we are using loc to get that. And then as well, loc does this by row then column. So this is telling us how many rows we wanted. If we wanted to, we could say we want all rows and then just 2 columns. So let's say we did df.loc and then we use the colon to say all rows, and then we do comma. Then in a list, we can pass in our column names that we want. So let's say we want release year. And then as well, we want rating. So now we're going to get every year or every row with release year and rating. And then as well, we can use actual columns and greater than, less than. So say we only wanted the data frame rows that had a release year greater than 2000. We could use that with a loc by saying df.loc, and then we'll say df release year is greater than 2000. So now this gives us all of the rows that were greater than 2000. As you can see, there are 4,403 rows that are in this data frame right here. So now what we can do with iloc is we can actually, instead of getting like rows and columns, we can get exact values or groups of values. So if we did df.iloc and then let's do 0,1, this is going to give us the value movie. So this is finding the exact row and column. It's saying it's in row 0, which in Python is our first row, and then in column 1, which technically is our second row. So it's going to give us that cell value if we're thinking about it in terms of like an Excel spreadsheet. So we come over here, first row, right there, movie is what we're looking at. We can also do this with certain types. We can pass in row groups and then column groups. So we'll say df.iloc, and then we can pass in, we just want row 0 and 1, and then we can put a comma and then say all columns, and we run this, and now we have the first and second rows and every column for that. So there's a lot of ways that you can filter data. Another one that's pretty popular and kind of a more simple way to understand it is you can just say df equals df and then df, then the column name. So we will do rating, and then let's say we only wanted our rated shows or movies. So we run this. Okay, so if we wanted to see the exact effects of that, we could just type in df again, and it is going to show us that we only have movies and TV shows rated R. We're down to 654 rows as well. So that is kind of how that goes, and filtering goes. Filtering is something that I do every single time just to get it so it's getting the right data and the data that I want that pertains to the analysis that I'm doing. And it's kind of one of the most commonly used things, loc and iloc. So being able to grasp those concepts is really going to help when manipulating data. Another thing you can notice is the row numbers over here actually don't reset. So to do a couple of other things that we're wanting to do, we can't have row numbers that go from 2 to 7 to 14. We need those to go from 0, 1, 2, and then all the way up to 654. So what we're going to do is we are going to do something called resetting the index. So we'll say df equals df.reset_index, like that with parentheses. And we can look at it again if we say df.head. And now you can see index has, the old index became a column, and our new index or row numbers are 0, 1, 2, 3, 4, and it should go all the way up to, we can do df.tail, and it goes all the way up to 653, so we have 654 rows. So most people actually might get rid of this column right here. So what we can do is we can just say df.equals df.drop, and then we'll just put in our column name. So we say column is index, and then we need to put in our axis equals 1 like we did before. And then we'll just say df.head again, just to make sure that worked. And now we have it. We have our reset index and our data frame that does not have the old index column. So the reason we did that is because if we want to loop over our data, it makes it a lot easier to loop over these numbers rather if they're like 0, 1, 2, 3, 4, rather than if they're how they were, where they were 1, 7, 17. So what we're going to do now is I'm going to show you how you can actually loop over this data frame. So the easiest way that I've found to do it, in a way that I know a lot of other people do it, is by looping over these row numbers. So we'll use a for loop, and we'll say for x in range, length, and then df dot, and you have to put in a column ID so it will loop over the amount of rows in a column. So I usually just put the first one, show ID, so we'll do show underscore ID. And then this is basically just a for loop. So we're gonna put a colon after that. And then what we can do is we can do a lot of things now, but say we want to print the show ID right here for every single row that we have rated R movie. So how we're gonna do this is it's kind of like looping and getting data from a JSON file. So we'll say print df, and then we need to say our column names. So we'll say df, and we will do show underscore ID. And then on the outside of this bracket, we need to put X. So what this is doing and how this works is we're going to say for X in range length df.showID, print df show ID X, where this first one is going to be our column name. And then X, every time that we do X, it's going to locate our row number, and it's going to get that cell. So right here we're saying for X, so for 0, 1, 2, 3, 4, 5 in this length of the column, and it's going to get every cell value, and it's then going to print it. So it's a little bit easier to see once I do this now. So it's super quick, and it printed every single show ID that's possible in that data frame, which was 654 different prints that it did. So it was super fast, but that's kind of how we can do it. Say we didn't want, though, we wanted to multiply something. We could say multiply by 5, or actually that is a string, so we can't do that. Or say we want to do some sort of if statement. We could say if df show underscore ID X is equal to, and then we'll just do the first one, S3. We can print, and then else, if we wanted to print something else, we can say print, and we can just say not right. I don't know. And I needed my colon right there. So it prints the first one, and then it says not right for every single other one. But say we had, what's a different one? S7779. So we do S7779. And then it's going to print not right for all of them until we get down to the bottom. It will print that last one. So that's kind of how you can loop over a for loop, and it allows you to do some cool things with data manipulation and different data editing and stuff, and you calling different data and locating data. So another thing that you might be doing with data is most of the time you're not in the data world, you're not just going to have one data frame or one Excel file or CSV or wherever you're getting your data from, you're most likely going to have 2 data frames. So what we can do is we can do a couple of things. The first one is called concatenation. So what we do is we can create a new data frame, which we will say df2. So we're going to say df2 equals df1. And then to create just kind of a random sample of this data frame, we'll say dot sample. And then we can just say n equals 100. So this is going to take 100 rows from our data frame, which is called data frame, not data frame 1. And it's just going to take a random sample of 100 rows. And then what we could do actually is we could concatenate data frame 2 onto our original data frame. So we'll do this just by saying df3, so we're creating a new data frame, equals pd.concat, and then we put in parentheses, and then we pass in a list of our data frame names. So we'll say df and df2. We do that, and now we can actually see the shape of our data frame. So we'll say df3.shape is 754, which is those 100 rows added on to our data frame that we had. And then as well, if we wanted to look at the head, it's still going to be the same as it was for the other one. Tail, though, will be different because it's going to be our added on rows. So that's kind of how we can add at the bottom of a data frame. As well, we can use something called append. So let's say that we didn't want to create a new data frame. We just wanted to append onto the bottom of our original data frame. We could say df.append, and then we just need to type in df2, and we do that, and it shows us what it would look like, the exact same thing. So concat is usually where we're wanting to create a brand new data frame, and then append is where we just want to append it onto the bottom of an existing data frame. So there's a couple different use cases for both of those, but usually I find myself appending more than I am concatenating, but it really depends on what you're doing and what your end goal is with the data. Another thing that Pandas is really good with is doing things called group by. So if you're familiar with group by or SQL or any sort of language where you can group data together, I think SQL is probably the best example of it. But in SQL, what you can do and what you can do with Pandas group by is you can group a column together by a specific value that's in that column, and you can get some statistics or some things about that value in that column. So what we're going to do is I'll just show you group by. It's super easy to do. You just say df.groupby. So you call your data frame and you say .groupby, and then you type in the column that you want to group. So we are going to do country. So we're going to group all of the countries together. So say df.groupbyCountry, and then we want to get the mean of each country. So the mean amount of rows for each one of these. So for Argentina, if the country is Argentina, the mean release year was 2006. So this gives you values on numerical data as well. And then you can see Australia, if it has a release, or a country of Australia, United Kingdom, Canada. Release year is 2014. This one might be a little bit harder because it seems like a lot of these columns or a lot of these countries are split into a lot of different countries rather than just being like the one country for each one of them. So you can actually do this as well if you wanted to group by anything else such as director or title, or if you want to do it by type. There's a lot of different things you can do. I'll show you type. So if we did df.groupby, and then we can do type, and then we can get a count on the type. So we only have movies, so we'll try df2, which is just movies as well. But you get the point of it's showing you exactly movie. So it gives you the count of how many movies there are. And then if we had TV shows, it would show up as TV show as well. So group by is actually a very powerful tool. It's something that you can use to get a lot of good statistics and create kind of sub data frames and sub columns and sub statistics as well. The next thing we can do within Pandas is we can actually just do some really quick visualizations where you're not needing to import any external packages. So if we want to, we can say df.hist, and just like that, it's going to plot a histogram for every single numerical value. So right here, release year, we can see it's very left skewed, and minus 100 is basically the same thing. New column, since we only have values of 5, it is only going to have the 1 bar. And then the last thing you can do, and kind of the last thing I'm going to show you, is how you can export the data. So as easy as it was to read in the data, you can actually export it just as easy. You just type df.to_CSV, and then you type in the name of you type in your path and the name of your file that you want. So if you just want to put it in the same path, you do final_netflix.csv, and you can run that. And then we can go to my desktop, and you can see over here, final netflix.csv has been exported, and it's not the same as Netflix titles. So that is everything for this tutorial and kind of how to get started with Pandas. Pandas is definitely the most used package you're going to be using in Python. If you're doing data analysis, data science, data engineering, anything with data, you really need to know and master Pandas, and it's going to help your life and your data analysis really be 10 times better and 10 times easier if you can understand what Pandas is doing. So that's it for this video. Thank you so much for watching. If you have any questions, be sure to leave a comment. If you'd like to subscribe to the channel, that would be great as well. So thanks, and we'll see you in the next one.